Let's wait for the recording to get going. There we go. So everybody, thank you so much for joining us for another session of the Data and AI Architecture Group. Today we have the amazing Kevin Wilkie presenting all about data types. This is going to blow your mind, folks. So without further ado, I'm going to pass it on to Kevin. Feel free to always check out our meetup page. We already have sessions booked all the way until the end of the year. I'm actually going to start booking stuff for January very soon in the next couple of weeks. So it's been great, the reception that we've gotten so far. So keep that in mind, reshare, and let's get the word out. And right to Kevin, I'm going to go on mute. If you have questions, feel free to use the chat and we'll just let Kevin answer as we go. Sounds good?
All right. Thank you so much, Warner. All right. As you know, finding raw data types. All right. So this is me. I've been doing all kinds of stuff in different database systems over the years. Over 15 years experience. I know Warner mostly from my work as in the DBA fundamentals group, where we also do various types like this. We actually, like Warner, we've already started getting folks and presentations ready for next year as well. And also, I'm a co-organizer of the data-driven community. We just had our conference yesterday. It's called the Future Data Conference. Hopefully, most of you were able to join that, or at least see or hear of it, or at least be a part of it for next year. Also, I've held a couple of titles over the years, dealing in different things in databases. So this makes sense when you see some of the stuff that I've seen. I've seen a lot, and I know there's more, so it's all good. All right, so let's get started here. Data types. We all know kind of what different data types are. It's just basically a classification of what type of value a variable can hold and the operations that can be performed on those values without causing errors. It's truly both of them combined because you can't have one without the other. Today I'm going to talk about 5 different data type categories: character strings, exact numerics, approximate numerics, date time, and other. There's a fair amount that goes in the other, so we'll go through and this will all kind of make sense as we start flowing through, and I'll show examples of everything here. All right, so let's start off with character data types. First, we want to start off with SQL Server, because that's what most of us are fairly familiar with. In SQL Server, we have the char data type, which is just a fixed width. Pretty simple. Then we have the varchar, which is a variable width. So you can have, and it allows more than one small space to put your data in. Also in SQL Server, we have nchar, which is the Unicode fixed width, and its sister data type, nvarchar, which is the Unicode variable width. But in SQL Server, we also have text, which Microsoft has been saying it will deprecate in a future version all the way since 2005. Yes, if you look out in Azure today, you can still see the text data type for whatever reason. One day, at some point, it will go away. And so says Microsoft. We'll see. On the Oracle side of it, we have the char fixed width data type, varchar, sounding a lot like SQL Server here so far. Then we have varchar 2. So on this one, it does look a little strange. Varchar and varchar 2 both do exist. Varchar, according to Oracle, should not be used any longer, though. It's there for very back things that have been worked on a long time ago and probably should not be used ever again, because like Microsoft, Oracle can take the idea and actually just get rid of it from some version in the future. Hasn't happened yet, but it could happen. Also, in Oracle, varchar 2 has a max length of 4,000. Just something to be aware of there. It also has nchar. It's the Unicode fixed width. Nvarchar, Unicode variable length. Thankfully, it does not have an nvarchar 2 because that will really mess people up. It is what it is. Also, Oracle has a club. which is where it stores 8 terabytes of character data, and InClub, which stores 8 terabytes of Unicode data. Yes, it's as odd as that. As with most things with InClub, remember it does store less true data than the club will, but if you need it for Unicode, you're kind of stuck. Also, with that, in Snowflake, which is obviously one of the big ones that people are starting to talk through and learn about now, which is one of the databases me and Warner were talking about just a minute ago that we use fairly often. They have car or character. It's really just truly varchar. It works the same way. String, which is just like varchar. Text, which is just like varchar. And varchar, which is obviously varchar. Snowflake doesn't care. It all works basically the same. The only true difference between here and how some of these are set up, in Snowflake, a varchar has a default and max length of 16,777,216 bytes. Yes, that's a lot. And yes, default is the max length for whatever reason. It is what it is. It's special as always. So with that, let me actually show you something in Snowflake. Not Snowflake, SQL Server. All right, so we're just going to create our little fun database. Let me actually switch this over to temp DB. All right, so we're going to create our fun table here. It's a simple temp table. We're going to insert into the table we just created. Notice that first name is a varchar, last name is an invarchar, full name is a varchar as well, but there are much differences in the length that is there. So for here, we're going to actually try to insert all this. You'll notice this very last one, Fred and Barney we get. And this has to be the longest first name. It's even longer last name. When we try to insert it, it's obviously more than 30 characters. We insert it, it gives us this fun error. String or binary data will be truncated in the table. It shows what the value itself is. Now, if on this one, if you were actually running a version before 2016, you don't even get this. You got to figure it out yourself. That's yet another reason to upgrade to 2016, because it definitely helps to be able to figure out what the value that you truncated was. Something you can bring up to your management if you're running a version older than 2016. So let's go ahead and just insert the ones we can here. Insert that works perfectly. We're going to actually update the full name to be just concatenation of the last name and first name. So when we look at it, we show here Fred full name has a length of 16. Barney's full name has a length of 14. Pretty simple. Then, and some of you may not be familiar with this actual function here, data length. As we'll show here in a minute, data length actually shows the true length of space that the field takes up in memory. We'll look at the first name, and I'll expand this out a little bit. Let me see if I got Zoom it running. I have Zoom it running. Go. All right, here we go. And of course it doesn't. It's not that far over to the screen. All right, try it again. Nope. All right. All right. So you can see here that Fred and So this one is showing, the length here is showing the first name, shows how large it is, 4 and 6, which makes perfect sense. Data length itself, though, is 4 and 6, but that's because it is a varchar. On last name, which is an in varchar, on the other hand, length is 10 for Fred and 20 is the data length. That's because Unicode takes up, as we have seen before, it actually takes up twice the amount of space as than a regular character will. So since it's in varchar, it does take double the length. Just something to be aware of when you're actually working as a DBA or have to see how big a table is or whatnot. So with that, let's go back to our little presentation here. All right, so we're done with strings. Oh, that all kind of makes sense. Exact numerics. So it stores exact numeric values. In other words, no scientific values. That's really all an exact numeric is. So bit or Boolean, yes, it is considered a exact numeric. This one's a little special. The reason it's done that is because of how it's actually stored. Most of us know it actually is stored, as I'll show here, it is stored as a 0 or a 1. Kind of. It's actually stored as a 0, 1, or a null. That is, for whatever reason, they decided to make that happen. But it does make sense. You can have 3 values for your data. It's just not probably a good idea in most cases, depending on how things are set up. As I say here also, it stands for true and false. 1 is true, false is 0, unless you say otherwise, which I have worked on applications that did that, which makes it great fun. Another thing to remember with bits, that when converted from another data type to a bit, any non-zero is true, which does make, if your logic is defined the other way, then yeah, good luck to you. You will have to remember that when actually inserting any data from using this little bit here. It does actually allow you to convert true and false into the bit. So yes, if you actually say the words true and false, it could be converted to a bit straight up. It can convert those without any logic necessary. Thing to remember, in Oracle, this does not exist. There is no bit. It is truly represented by what we'll show here in a minute is just the number and then 1. It's yeah. In Salesforce, it is actually supported for accounts that were provisioned after January 25th, 2016. If your account was provisioned before then, you do not have a bit operator. Something to be aware of with clients, especially ones that have been on Snowflake for a very long time. Integer. This is one that most of us will use frequently. Integers are whole numbers, no decimals. SQL Server and Oracle both set the allowed value to the same size. You just call it different things. For example, SQL Server is an int, Oracle is an integer, small int versus short integer, big int versus long integer. They both mean the same things. So if you use one, just remember to call it the right names. Yep. Okay. So on Snowflake, for this, they actually all correspond to the same number. It's the max. I believe it is. No, it's this one. They all correspond to this one. Since you didn't tell it how big you actually want it, it's all just like this. Something to be aware of as you're working in Snowflake. Tiny int. Some of us may never have seen this one. It is an extremely small value. Like I show here, it is truly between 0 and 255. No negative numbers, and that is the entire value you're going to get between those two numbers. I actually used this a few times for some of the data I have. It is, for example, and since I work in healthcare, one of the things we use to track people is how many times that they've come through certain operations. Hopefully, you'll never have to come through these operations more than 10. But since there is no way to actually specify that you'll only be maxed at 10 at least in this format, we actually have logic in place. This is as good as you're going to get, at least as the database is concerned. So we force it to stop at 255. This has actually caused a couple of errors when we met. We screwed up some logic. We had people go over 255, and this will easily let us figure that one out. So this actually saved us a few times. Yeah, like I said, no negative numbers. Also, Oracle does not allow this. There's no way for this to happen. You actually go through and use another process to show this. You just call it a number and give it a number of bytes to use. Let's see if I have on this one. Oh, this decimals. All right. We'll get to that here in a minute. All right. Numbers with decimals. SQL Server, Oracle, and Snowflake all have to know two things when you're dealing with decimal numbers: precision and scale. So definitions. Precision. Precision is the maximum number of digits stored. On SQL Server is 18. Snowflake and Oracle both is 38. So it's really large in Oracle and Snowflake. Scale, on the other hand, is the maximum number of digits stored to the right of the decimal point. Thankfully for that, default is 0 for all three databases, so you don't have to actually have a number to the right of the decimal. It's just a way to show it. On Oracle, you have to actually, when you're showing off the number, in this case, it does have to have precision. So the default's a little weird there on that one because you have to actually have a precision for Oracle or it will actually fail. It will give you an error. And I'll show you kind of an example of that here in just a second. SQL Server and Oracle are very different in the sizes allowed for all your numerics, all your decimals. So SQL Server, decimal, numeric are exactly the same thing. They just give it two different data types just so you can. I'm not sure why they decided to put both of those out there for this. On Oracle, on the other hand, a short decimal is what SQL Server calls a decimal. Decimal is up to 10 to the 308th power. Number is 10 to the 125th power. It is what it is. On that one, Snowflake. Number is 10 to the 38, numeric 10 to the 38, decimal 10 to the 38. It's exactly, that's where it maxes out at. It is what it is, like I said. Let's go through decimals here. All right. For the below query, if a normal person were to calculate it, what data type would be used? And then more importantly, what data type does SQL Server return? So as a normal human, I say that because I've asked what a normal human actually does, because I'm not one. Selecting 1 divided by 2, even my youngest daughter knows this one. It's truly just a half. So it's 0.5. It's a decimal. But when SQL Server runs it, and I'm sure people have come up to this many times, it shows it 0 because this is integers, what way it sees it as. So what data type should SQL Server return for these? Because large numbers divided by 2. It's going to be integers again, right? Not quite. Notice this one. It truly is. This is the tipping point for this one to actually make it where it actually flips over into decimal land to return data types. Something to be aware of. What does happen when you go outside the limits of a data type? We're going to drop our little table here, create a tiny int. We're going to put the number 254. Now remember, 255 is the magic number for this one. Reselect our from the table. Yes, no tricks up our sleeve. 254 is a number in here. Now we're just going to add 2 to it. Arithmetic overflow, because it shows what the value would have been, but it won't let you. So thankfully, at least SQL Server will remind you that this is an error and stop you from doing stupidity, or at least stupidity according to your data types. Something to be aware of. All right. Now, a more fun one. Money. Some of us have actually got to play around with the money data type in SQL Server. This one has small money, which goes down to negative 214,000 up to 214,000. But you have money, which is 922 bajillion. That's a lot. Hopefully you never have to really need to use that one, but it is available. Small money should do most people if you need to use the money data type at all. So it is available. Oracle and Snowflake don't have money data types. They just want you to use number 19.4. So the precision on this one is 19, and 4 would be the numbers after the decimal. Let's go into a quick demo on that one. Oh, sorry, I didn't finish with the decimal one. All right, so this is what I was talking about here. Let's create a decimal data type, and we create a decimal data type table. Let's decimal, numeric, decimal. This one actually is a little odd. It's something you can do in Oracle. You can actually have a negative scale. So what happens here is this shows it'll only go down to the number of hundreds in this case, because it's -2 data scale. You could do negative, if you just cared about thousands, you can actually force it to round it to the thousands. That's only in Oracle, not SQL Server. For whatever reason, one way or another, you cannot do negatives. It will actually throw an error at you if you try that one. I show here. Specified scale -2 is invalid. So that's why I just show that one there. Push this back. Oh, I've already pushed it in. All right. Insert into our decimal data type and run it. All right. So with that, we've put in there, this is a decimal, this is a numeric, and this is just a decimal again. I'm going to show you something a little odd here. How are we affected when we have divide or multiply for these? So in this case, I've done one decimal, a decimal divided by the number, and the decimal times the number. So for that, we get small, really small numbers, because if I remember right, yep, the negative, the numeric is negative. All right. So with that, we're going to actually take some numbers here and actually do some goodness, because you'll notice for these, at least, there is a lot of precision or scale after the decimal point. We want to actually show some of this off. So here we take we choose two totally different decimals, 20.5 and 27.52. We're actually going to insert them into the decimal data type table. This is just how I set it up to divide. Notice it's 1 divided by 2, 2 divided by 1, and then 1 times 2. Push this all into there. So we have another value. Notice these are 4 after the decimal. This is exactly what we expected, because 2 and 2. And that plus the fact that up here I actually set the scale to be 4. So now we come down here. We want to do something. We're going to do this a little different. So what does this return? So we have the same numbers here. You'll notice decimal 1, 20.5, 27.52. There is no tricks up my sleeve on this one. We actually want to figure out where 1 decimal, which is, this one, gets the value decimal 1 divided by decimal 2. So what should happen here is that we actually get the value that we put in right here. It's the exact same things. When we run it, you'll notice it comes back with nothing. So that's because of the scale. So if we had changed the scale to be 2 instead of the 4 and worked with these different numbers a little bit, sometimes you'll actually get this to show up right. Thing is, this is why we do not, as much as we can anyway, use the divide over here inside this to figure out where you can grab where this value is, because you will run into troubles just like we showed here, because there's definitely some issues if you try to pull that data, because it just doesn't pull. All right, so now I'll continue on with where I was. I forgot about that one. You drop it, we're going to do money. So we're going to create our little money table. Notice this total money and portion money. So what I've got here, we have values that people have given us a total amount, and they have paid a portion of it. So we put that all into the system. We're actually going to take and display all of these values. So portion, total, and how much percentage is. Now, having seen this, you should be like, oh, that's great. Except a little bit of QA in me stands out and says, oh, we should check these values because something doesn't. I just want to make sure that people can figure this out right. So we take the first number. Well, actually, let's be different here. Let's actually take row number 3. 179.00 divided by 389.00. It is 46.015%, which does not. So you'll notice here, this one would show that it rounds up to 46.02%, where SQL Server showed it as 46.1. So it rounds down. So does that happen often? Let's just see. Let's check this one. 4316 divided by 4639. 93.037, which is 93.04%. So it doesn't quite work. Kinda. So the problem is, this is what you truly would have to work with to actually get the values to show right. They did change. It actually shows up correct this way. Notice that most of the problem is the fact that you're actually working with money up here. Down here, we actually convert it to decimals so that it does show this all correctly, and it will actually spit out correctly. The money type, because it is it only goes up to 4 spaces after the decimal point. When you multiply it by 100, that moves it to the left, and it has already dropped everything after that. So it's right to a point. If you need precision, especially like this, and you have to use the percent, the multiply by 100 to get the percentage, don't use money. It's not worth it, because you'll miss sometimes. And they like I show here, it's definitely not an edge case. It happens frequently. All right. So with that, I'm going to close out my calculator here. Go back to our slideshow. All right. Approximate numerics. By that, I mean truly what represents a real number, but it's actually an approximation of a number. So pi, epsilon, mega, things like that, that are not even, they're a number, but they're not. At least not that can be actually showed easily in SQL Server or any databases. One of the reasons you actually have and use the approximate numerics is floating points. The term floating point refers to the fact that the decimal point can be placed anywhere relative to the significant digits of the number. So you'll end up having things like this. It's really great for actually working with galaxies or atoms. So really, really big or really, really small. And that's about it. In SQL Server, you have real and floats. There is a big difference in what can be held in those. These are the two values for those. Oracle has binary floats or binary doubles, which it's approximately the same thing. You do have to remember where these numbers are. Snowflake, on the other hand, actually has a float, which is these numbers, which is really, really small and really, really large. All the same thing. It does have double and real. Those are just set up the exact same way. There's no difference in Snowflake. One of the big things about floating points for all of these systems, the floating point data type actually takes advantage of hardware acceleration. That's the only reason they really should be used. That's really that's, like I said, it's the only reason to use them, just so they can have better performance for numerical computations. If you have floats in your databases and you really want to be good about using them, only use it, like I say here, really big, really small things. Otherwise, it's just a number. You can actually show it more efficiently because there's no hardware acceleration that can be done on any of these. That's just really a number, just because. All right. Dates and times. SQL Server. There's a lot of them. Date time, date time two, small date time, date time offset. There's all kinds of goodness here. These are the minimum and maximum of all of them. Notice date time two, you can get to the year one. There is, in date, you can now, if a small point, if you are playing with dates and your system actually uses date time still, make sure it's not, you don't have any, well, obviously in date time, you won't have anything above 1753. I know I get it. So like I said earlier, I am in healthcare. Sometimes we have people that mistype in things. It becomes 1683 per year for somebody's birth. All kinds of things happen. We do catch things like this. But thing to remember with date time two, it is actually stored more efficiently in SQL Server than it does with date time. They actually made it more efficient, and it actually saves space on your servers if you use date time two. If you have a lot of date, be good to be cognizant of that fact. Yes, as I show here, make sure you actually can go to quite a number of decimals past with a date time two. Date time, most people will be fine if you only go to 3 decimals past, but you can get up to a lot more with date time too. Also, no small date time. The year 2079, I don't know why they picked that one as the max date, especially June. It does seem a little weird, but that's what it is. On Oracle, it is the date actually can go to negative 4712. Yes, that is the year 4713 BCE. So very, 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 very long time ago. If you need to put things back to that date in a database, more of the power to you. Don't know why you would, but I am sure there is some use case for that. And you can do the end of time, at least as far as we're all concerned, except for those who have to deal with live 4K. Good luck to them. And Snowflake, you can have the dates January 1st, year 0, or you can do, like I said, the year end of time. This is how, for anyone who hasn't got to play in Snowflake yet, this is how it actually stores time normally. Yes, you can put it into normal way, the quote unquote normal way. Whoa, a lot there. But it will actually push it all back to this format if it's showing you natively. So be used to that, or get used to that. And this one, I do like to bring up the fact that this one you can actually set the precision of how far, and as well you can do it in date time 2 format for SQL Server. Set how precise you want it, however many places after the decimal. Also, Oracle actually uses the astronomical system for calculating Julian days, as opposed to SQL Server and Snowflake, which use the Gregorian days. Oh, there is one thing I wanted to show on dates here. I remember, right? Yep. All right. Fun with dates. That is what I like to call this section. So we just have 3 normal dates. Notice I use the YMMDD format, just to make life easier, a little easier for me. So this was back in 2021. We have stuff from January 14th, July 11th, and July 21st. All right. So when we do this, if you just look at it by the naked eye, you'll see that these, between date 1 and date 2, there is a little less than 6 months difference between them. And between date 3 and date 1, there is over 6 months. But when we run it in SQL Server, oh, sorry, absolutely. The day is not a day for that. Here we go. There we go. All right. Notice SQL Server shows them both as 6. It's close, but not quite right. So like I said, I'm in healthcare, and one of the things we have to deal with is we have to actually pay very close attention to however long ago, to the actual ages of a patient. It can't be off even slightly. And so sometimes this, if you don't use the correct formula, this will come and bite you because it's not right. Several other things, several processes. If you're doing date time calculations, if you're doing month, it's not quite it. So there are several you can find online that will actually do this one correctly. I'll let you pick out your favorites that do actually work. Good luck. There are some, just be sure to actually check them. If you actually care, it has to be exact. Be sure to pay attention to your date type, that your process actually works as expected. As always, good QA, show off where this actually affects. All right. So with that one, I actually want to show some of these different functions here and what they actually return. So we run this one as SQL Server actually states for you. I'll just run all of them actually here, make it a little easier for us. Get date actually returns, yep, date time. Sys date time returns date time 2 with a 7. So as you see here, it actually has up to 7 points after the decimal, 7 numbers to the right of the decimal. Get UTC date returns a date time. The sys UTC date time returns date time 27, where sys date time offset returns the date time offset with 7. So 7 points after the decimal. Yeah, as you see, they're all very different. They all can do a very different answer. You just have to be aware of what you can store in each of them. I think that's it. Yep. All right. So other data types. We have binary, var binary. So binary, let's explain what that one is. For most of us, probably not familiar with that one. Binary is a fixed length binary data where a length of n bytes, where n is a value from 1 to 8,000. Yeah, it's rather large. We also have var binary, which is a variable length binary data. We have GUIDs, or unique identifiers, as SQL Server likes to call it. Most of us are probably familiar with that one. I had to play with GUIDs. We have XML, which is a data type that some of us may have used in the past. It does really good for when you're working with actual XML, so you can watch the data type to make sure it is actually well formed. We also have geometry and geography that most of us are probably not familiar with and hadn't had to use. The fun thing to remember about these, geometry is just coordinate data, where geography is the latitude and longitude. They're both actually implemented behind the scenes using CLR. So yes, your C# stuff, that one actually got come into play here. It actually makes these two available to us. Yeah. So on that one, let's actually show binary. And I got a little fun thing to work with binary. So in this case, we're actually just declaring a binary variable, give it the type binary 2. As we all know, as we remember, that means it has a length of 2 bytes. So we're going to set the binary variable equal to 1, 2, 3, 4, 5, 6, and then we'll add 1 to it. Show what it shows. All right. So when we run it, it gives us a value of 57921. That's probably not what most people expected. Just be aware, this one is going to be very different, because if I show you this right here, 57920, things like it's not truly a number. It is a little different than a number. It's something, if you ever had to play with binaries, that can be cool. There's a couple of use cases for them, but they're not. Just don't think of them as numbers, because they're not. That's it. Yeah, that's it for SQL Server. On Snowflake, we have a little bit of different things as well. We have objects. Yes, that is what we think of in C# as object-oriented programming. You can use that in Snowflake as well. We have variants, so you can pretty much shove whatever you feel like in there and work with it from that point. Yes, there are a couple of use cases where you want to use something different than a string for working with it. We also have arrays. So yes, your original programming you did back in school, learn about arrays. It actually can come into being useful in Snowflake. I actually play with these fair amount for different things. It's just an easier way to keep data in there. And if you have any of your object-oriented programmers in Java, C#, you name it, they can play in arrays very quickly and efficiently, also with Snowflake in this as well, just by using the array data type. And there are several functions Snowflake has built in to work with them as well too. Then we also have geography in Snowflake. In Oracle, there are three other, what I call other data types. So objects, XML types, which is truly just XML, as well as the row ID. So with that, I am now open for questions. Hopefully there's been some questions y'all have thought of, use cases, whatnot for any of this stuff. If you have, as always, if you have any questions, reach out to me on my website, sherpaofdata.com. You can always hit me up on LinkedIn or Twitter or even my email account. So with that, Warner, do you have any questions?
Yeah, we have some comments, not necessarily. Well, we have one question. We have some comments as well about Oracle and some of the support that Oracle has, like for example, JSON as well. Yeah, Oracle has, a bazillion data types too. It's pretty crazy. I mean, the Oracle obviously has been like available for so long. Interesting thing about somebody says SQL Server has JSON, but it's not really a data type. I don't know if you want to go into that, Kevin, about JSON in SQL Server.
So it's, yeah, it's a variation of it. Most people will never or should not use the JSON data type, at least from what I have seen. It's not what you want to think, and not really, at least from what I've seen, is usable if you want to have in there true JSON. Most people, will just put it into a big varchar max and work with it from there. Have you had that same experience, Warner?
Well, so the JSON in SQL Server, it is a varchar, right? So there's nothing. It's kind of interesting because when they did the XML data type, they actually did create a new data type, and it's dependent on the CLR stuff, right? I don't know if people realize, like some of these data types in SQL, like XML and I think geography and hierarchy, these all were implemented with .NET behind the scenes, right? But with the JSON, all they did was put it on top of a varchar. So I don't know if they really did any optimizations to it. Maybe the parser is there, right? You can do open JSON and then convert in and out of JSON, but at the end of the day, it is a varchar. And Snowflake, I don't have experience with the Oracle JSON, but I do know Snowflake did invest quite a bit of resources in making JSON very, very performant in a Snowflake, right? With that variant data type, which is a very interesting data type because it's like you can do anything really. You can make a whole
Literally.
database of variants and store anything in it. Obviously, not that we're recommending you do that, but yeah, it's very interesting. I
Please
think
don't
somebody has
ever.
a raised hand. If you want to unmute yourself, you'd suck. You can do that, and or just put the question in the chat or the comment.
Sure.
It's up to you.
This is
There you
Isaac. I unmuted myself because I put quite a few comments. Thank you very much, Kevin, for a great, very important subject. I can add like few minefields what not to do with data types. I'm in an environment where if you create database, most varchars were n varchars, and that's why databases are inflated, doubled.
Yeah, that's
This is
true.
unbelievable,
Common
like
issue.
common mistake.
Yeah.
Back
Something
to the
else that
Oracle.
happens with that mistake, it's I guess people don't realize when they're querying that the engine's doing a bazillion implicit conversions behind the scenes too, in
Yeah,
the execution plans and stuff like that,
it's
right?
more
Yeah.
than meet the eye because we don't see it in our eye.
Yep.
The
Exactly.
Benevolent
That's
land
why I like the data lab
betrays us, the
function
function
that I
land.
showed, because it shows easily. You can see, oh, this is not the right size. It should be. Let's convert it all.
Yeah, my first comment was about Oracle. In 12c, they increased the varchar 2 and varchar 2 to 32K. It's more than a decade ago, and it was a wave of like campaigns converting club to this varchar. Just one switch in Oracle, and it increases from 4K to 32 basically for a decade. important to know about it because many still using clubs when there is no need in Oracle environment.
Yeah, and SQL is still, I mean, if it's in row, it still has to fall in the 8K, right? Even today.
Yeah, it's still okay.
Yeah.
Yeah, I don't think that'll ever change, sadly.
Yeah. In our comment about the date time, it's in our minefield. I am in Florida, and Florida single state has 2 time zones. So none of the data types is basically usable here outside of daytime offset. Because inside one single state, you don't know when it happened.
That's true. You have already different times.
And also, when, let's say, you share data with any organization, vendor, or whoever it is, if you don't have time zone, your daytime means nothing. It's unknown when it's happening.
Yeah, very true. Especially nowadays with all the global operations, right? It does,
exactly.
4 p.m. is like, it doesn't mean anything. 4 p.m. where? Yeah.
And to make it even more fun, if you're in Azure, your date time is what is GMT. So
whatever.
You can really get confused
if you're in a past service. Yeah, if you're in a past service, you gotta definitely know what your provider is using when they're giving you a daytime, right? Whether they're giving you UTC or sometimes it's like the timestamp of whatever server it's running. Who knows? You gotta check that out for sure.
Yes.
It is extremely important. Yep.
And one more area I would like to touch, it is XML and JSON. In SQL Server, textual XML is stored in a binary format, and it is compressed. And that's why if you'll store XML and identical JSON, XML will take significantly less storage space than JSON. Again, not exactly the truth, whatever meets the eye. SQL Server doesn't have right now data type for JSON.
It's not a real
nvarchar max.
Yeah, it's just nvarchar.
And it is coming. Microsoft already implemented JSON data type following the Oracle steps because Oracle already has official JSON data type. Back to XML, it's a fantastic data type. I personally use it a lot because it has a support with the XQuery and XSD validation. And XSD validation, by the way, has 49 data types.
Oh my God, that's the inside the
because it was
XML.
Invented for data interchange between loosely coupled systems.
Makes sense.
And it has tremendous semantical knowledge,
so
meaning.
You have data type inside the data type.
Exactly. Let's say we use for age, right? Let's say we can use, let's say, tiny integer up to 255. But many people using, let's say, integer, it could be negative. And by mistake, age could be negative 50, negative whatever.
Yeah. Benjamin Button, like that movie.
In XSD has all these data types exactly filtering out what's not needed. And XQuery is a fantastic language. Problem with JSON, exactly as again Kevin mentioned, you can store it, you can unpack JSON into relational, but there is no true language. But XML has XQuery, you can do whatever manipulation needed.
Yep.
And it creates a problem. You need to convert JSON into a relational format, manipulate it, and after that format it back to JSON.
Yeah, that's what happens a lot with Snowflake too.
I placed
use that in Snowflake.
I placed a request to Microsoft a long time ago to the Azure Feedback Now, the latest website, to introduce through API. Finally, we opened it up.
Well, we'll see. It says somebody made a comment here. Mikhail says that Bob Ward said yesterday that it's coming, but didn't say when. But we'll see. Maybe it's SQL 2024. It'll be out in Azure SQL DB before. We have another question. I think it's the last one. Smita says, Snowflake, how does one convert from binary to string? I think it really would depend on what you stored there. Like, what does your binary represent, right? It's not like you can convert any binary to a string, right? It has to be a proper binary representation of one of the formats that Snowflake supports for characters, right?
The other question is, should you? Because you obviously wouldn't want to do like I showed,
Yeah, it would be
SQL
kind of
Server.
weird. Why would you need to store strings as binary, or why would you need to
Or
convert them from
binaries to
binary?
strings.
Yeah, I don't know, but that's that will depend on what how those binaries were encoded, right? That's an encoding decoding issue.
Yep.
I have a scenario when to do that. Many characters are invisible. So when we do select, we don't see them. When we store them as binary, they're preserved.
That's a good point. Yeah, if you were to, that's also a data quality issue too, right? Like how or why we're capturing these invisible characters as well. But anyway,
Well,
yeah.
this is
But it is a
actually,
decoding problem.
yeah, there is a hex decode binary function in Snowflake, but it doesn't always seem to do it right. And there is also one of the reasons that this kind of non-displayable and other characters that come in is a customer entering data on the website, and they might sometimes enter, yeah.
Every time you gave a customer or an end user a free text field, you can say bye-bye to your data quality.
Yeah,
Bye-bye,
exactly.
data quality.
Mm-hmm.
You'll
Drop
get
down for the win.
controls, invisible controls, tabs, all kinds of stuff. That's true.
Yep, exactly.
Yeah. All right.
I haven't
point.
seen a
Thank
case
you.
where the binary does something weird that I don't expect. I'll actually play with that. See if I can get it to show anything different.
All right, we
Great
have
example.
one more minute. One more minute, everybody. So I don't know if there was one last question, Kevin. It was if you were gonna share the slides, and or if you share the scripts or not, as well.
Yeah, I can actually share this slide with you, if you like, Warner, and then you can pass out as you'd like.
Yeah, sure. That sounds good. And the contacts there for Kevin, you guys have them right there on the screen. And once again, just thank you everybody for joining us today. Thank you, Kevin, as well for joining us. The conversation at the end was also very rich, so I'm glad that we got that recorded as well. Check the website for the next sessions. Thank you, Kevin, again. Until next time, stay safe. Have a good day. Bye-bye.
See y'all.
Thank you. Bye-bye.